Hello there. I am going to talk to you about the lab for 2.04, natural selection, evolution and natural selection. This lab is a lot of fun. I had a lot of fun doing it, but you also have to pay attention about why you're doing what you're doing in this lab. So make sure that you're thinking about that as you do the activity. As always, I've created a forced Google document, so when you come to the landing page, you see the lesson pages. You're also going to see a link to open up the forced copy of the lab report. When you come to the last page of the lesson pages, the lab is right here. It is a simulation for natural selection. In this lab, you're going to be exploring the scientific theory of evolution by recognizing and explaining ways in which genetic variation and environmental factors contribute to evolution by natural selection and diversity of organisms. Oh, that sounds kind of like an objective. And listed below are some bulleted points for the objective. That's the reason you're doing this. So make sure you take these objectives that you're listening to and reading on your own, rewrite them in your own words, because that's the objective of this lab. That's why we're doing it. We're going to be able to identify different types of evolutionary adaptations. You're going to be able to explain ways in which genetic variation and environmental factors contribute to evolution and by natural selection and diversity. I'm reading these bulleted points right here. We're going to be able to simulate the effects of natural selection and genetic variation under specific environmental conditions. Some background information. This man named Bernard Kettlewell, probably not the first name that comes to mind when famous scientists are talked about. He's quite a big name when it comes to the area of natural selection. He was a biologist and moth collector who first noticed that the color of a moth impacted its survival. He found that dark moths had a better chance of survival than light moths due to the change in tree color caused by soot from factories during the Industrial Revolution. Remember why those trees became darker in color. You're going to need that later. All right, so let's learn a little bit about these peppered moths. Peppered moths can be two different colors depending on their genetic variation, light colored and dark colored. The dark coloration was caused by a mutation in the DNA. The light colored peppered moth, I'm sorry, the dark coloration was caused by a mutation in the DNA of the light colored peppered moth. The mutated gene was then passed on from parent to offspring. This is important because the moths need to camouflage themselves against the trees for survival. Dark-colored moths blend in better on trees with dark bark. Light-colored moths blend in better on trees with lichen or light bark. Light-colored moths on a dark tree are a much easier target for predators, and the reverse is true for dark-colored moths. As the number of soot-colored trees increased in the environment, Kettlewell observed that the dark moth population began to increase, while the light moth population began to decrease over time. He wanted to find out why this was happening, and began collecting evidence to support his observations. Let's join Kettlewell to further investigate the process of natural selection. All right, so we're going to take a closer look at these peppered moths, how they camouflage, and how the process of natural selection caused the population of peppered moths in this environment to become darker over time. We can drag him over the bark and see how the camouflage on the light bark makes it hard for predators to see him. But when we put him on that dark bark, he's easily seen, making him vulnerable to attacks. Some information about the predator. These three known predators of peppered moths are displayed here. Notice their various beak shapes, and you can read more about each one: the flycatcher, the nuthatch, and the European robin. All right, this is where you make your hypothesis. You're going to be testing both light-colored bark and dark-colored bark environments to see how it affects the population of peppered moths over several generations. For the first investigation, you may choose to test either light or dark bark for your hypothesis. At the end of the first investigation, you're going to come back to this screen and choose the other bark type for your second investigation. So here's your hypothesis that you're going to need to copy and paste into your lab report. If I investigate I'm going to pick the light colored bark environment, then I will observe an increase in the population of light colored peppered moths or a decrease. Here are the instructions. We're going to get ready. Here we go. So now we have a timer. This is the fun part. So we get to eat as many moths as we can click on. Now, there are light colored moths on here too. You have to find them. They're there. Just keep clicking away, finding moths to eat. And then when you're done, it tells you that the light moth population reduced to 56% and the dark moth population reduced to 44%. So I'm going to put that information in my table. Light moth was 56. The dark moth was 44. Save that. And we're going to do a repeated trial. Now, again, remember I told you, why are we doing this? Remember, this is fun, but you have to remember why we are doing this. What are you noticing? What's happening? Those white moths are there. Okay. This time, the light moth population reduced 70% and the dark moth population reduced 30%. And we go again. All right, so I'm going to continue filling out my table and then I will bring you back. All right, make sure as you enter data into your table, you click that save button before you hit the back button to return for your next trial. Otherwise, it won't let you play the game or do the activity. So once you figured out and completed your table, you're going to get this conclusion box. The peppered moth simulation should have given you a good idea of how natural selection works. Let's summarize your observations from this lab. First, identify different types of evolutionary adaptations, things like camouflage, mimicry, body shape, and teeth and beak types. Explain ways in which genetic variation and environmental factors contribute to evolution by natural selection and diversity. Simulate the effects of natural selection and genetic variation under specific environmental conditions. Those were our objectives in the beginning, and that activity, that's what I said, make sure you're thinking about why you're doing as the bird, why you're doing what you're doing. All right, we're coming to the end of this first lab. We're going to select the data table. You can print your observations or record them on the copy of your lab report. So let's take a look at the lab report. Put your name, my name as the instructor, the date, and the name of the lab. The name of the lab is Evolution and Natural Selection. The objective, in your own words. I don't want to see copied information from anywhere. If I see words and text that doesn't look like 7th grade writing, I will do a search and find where you got it from, and you will not get points for it. So take that objective from the first page, or the early pages of the lab. Write it in your own words. Why are we doing this experiment? So the hypothesis must be written in an if-then format, and it comes directly from the lab. So for the light colored bark, which we just did, if I use the light colored bark, I will notice an increase or decrease in the population of light colored moths. Whatever I chose, I'm going to copy and paste that here. Same for when we repeat it next in the dark colored bark. The procedure, you do not have to list the steps of this lab report, but you do have to list the independent variable and the dependent variable. This is something that a lot of students are skipping. Please don't skip this. It's important. Remember, the test variable is the thing that changes. What changes when we do this lab report? Certain things stay the same, but something changes. The outcome is the thing that we're actually counting. The numbers that you're putting in the data box are the things that you are counting. So the outcome variable, or what you are counting, list that here. The test variable and what changed, put that here. We're talking about things like the color of the moth, the bird, the tree color. Those are the things that are included in test variables and outcome variables. Scrolling down, this is where you are going to copy the information from that data box. Make sure you follow here the light colored tree and then the dark colored tree. Once you've completed that, you're going to answer these conclusion questions. Make sure you are writing in complete sentences and that the work is your own and it is not copied or pasted. So when I come back to the lab, I'm going to restart. And now this time it tells me I have to do the dark colored bark environment. I pick whatever hypothesis I want that I think is correct. I copy it and put it into the lab report up here. Hypothesis for dark colored bark. And then I continue with the activity. And now you can see we have dark colored bark. So same thing. As the bird, pay attention to why you're doing what you're doing. There are dark colored moths on this tree, and you can find them. I just got a couple. My light moth population was 45%. The dark moth population was 55%. Save this, or it will not let you go back and do the next trial. And continue through all of this until you have your data table completed that you can then enter into this lab report right here under dark colored tree. All right, if you have any questions or need help, please know you can always reach out, email, book an appointment with me. I am happy to help you. Good luck. I look forward to seeing your lab reports. Again, I think this is a fun one. Bye, guys.